All right, I am back on day 2 of the Data Connect conference hosted by Women in Analytics, and I am joined right now with the CEO of Aperture Database, a relatively new startup, Vishakha Gupta. Vishakha, thank you so much for sitting down and chatting with me.
Yeah, thank you so much for this impromptu conversation.
Yeah. It's an impromptu, and it's the first time we've done this. We're a relatively new podcast, but I would love if you could just share with the listeners that we have, a little bit more about Aperture DB and what motivated you to start it.
Yeah, happy to. I think I can talk endlessly about it, so I'll keep it short. The way we got started is, back a few years back when we were at Intel, we were part of this Science and Technology Center.
Mm-hmm.
And the goal there was, what happens when your workload predominantly becomes machine learning on complex data types.
Mm-hmm.
So, at the time we were looking at images and videos, and we started working with data scientists and data engineers, and we were systems people. And what we realized when we looked at the way data infrastructure was set up and the data tools that were available, it was extremely scattered. Invariably, unstructured data is still accompanied by some metadata that describes it, where it comes from, as simple as an image will have which camera captured it,
Mm-hmm.
or who is in this. Like, you would label it and figure it out,
Yeah.
right? But the way, if you wanted to search by, okay, give me all the images that were captured by camera 7, or give me who was present in this image, if you looked at how would you index and store this data,
Mm-hmm.
you had to deal with at least 2 systems, if not more.
Mm-hmm.
One would be a database to index the metadata. Then you take the images themselves and put them in cloud buckets or file system. And because these data types required some form, like, okay, if you're going to display, they're not just simple like columns and numbers that you can display. So people would end up with like OpenCV or FFmpeg type libraries, especially if they were going to videos and stuff. So if you look at the way data scientists started putting these things together, there would be a script to write a query to some table,
Mm-hmm.
find the links, and go to the bucket or whatever. It didn't, like, if you go to big companies, that would take a long time to get permissions and
Yeah.
find out which tables are the correct ones. And then if for display purposes, you'd have to process them into the right format.
Mm-hmm.
Now, that was just the starting point, and this was as simple as, I'm creating a training data set.
Mm-hmm.
So we started observing that. We talked to people across different verticals,
Mm-hmm.
healthcare, sports, retail, and then we learned more about, this becomes even more complicated with videos,
Mm-hmm.
because even if you want a little clip of the video, you have to download the whole gigabyte size file.
Mm-hmm.
It may not sit in your memory, so resource allocation problems. And then as we advanced more in our discovery, we learned problems with this sort of data, you don't always just do keyword search. Sometimes it's annotation-based search because you got the data annotated. And more recently, you might have heard about vector search.
Mm-hmm.
And that has been a way to find data by similarity.
Mm-hmm.
And that means you introduce a vector database or some library. Annotations are a whole different, like, index those formats.
Yeah.
Maybe now you have to introduce a new database to index them. So if you imagine all the steps I told you,
Mm-hmm.
you're talking about 3, 4, 5 different data tools
Mm-hmm.
to take the data you wanted, to feed it into downstream, either for training, inference, or just querying the data. And if you are a data scientist or data engineer, that's not your primary job. Your primary job is to be like using the data to understand something and drive a business decision. And so that's kind of what got us thinking, why can't there be a simpler solution?
Yeah.
And we understood that there have been all these databases, but the landscape was changing.
Mm-hmm.
These are new applications. There's a new way of utilizing this sort of data. And that's what got us on the path of building Aperture DB.
Mm-hmm.
And, one thing we realized, if you really want to do a good job and make it available to data scientists, data engineers, ML teams from a variety of different companies, the way to do that would be as a full-fledged supported product in a company.
Yeah.
So that's kind of what led to Aperture Data.
That's incredible. And I think just honing in on the specific problem of just taking all those various steps, I guess what motivated you less what motivated you, but how did you define that problem concretely to know that it was really the subset of tooling and all of these steps that there was a problem that you wanted to solve for, as opposed to any other myriad of problems we have in our data pipelines and ingestion points. I've consulted with several companies, and I think a lot of folks are they've run the gamut across data literacy in these organizations, and I'm just blown away by the various problems there are to solve in this space.
Right.
So why this one? Like, what really is this was your solution?
Well, I think part of it was just how we got led to the situation, and part of it was like my previous work.
Mm-hmm.
So I was, so we were looking at new memory technologies.
Yeah.
And when you introduce something that's way faster than even SSDs and can sit on your memory bus, the system software definition and the way database is written can change. And so we were actually creating our own graph database.
Yeah.
And I was really fascinated by property graphs at the time. And so we basically started, like, as a research effort, we started building a new graph database. Like, graph models are really good. Like, today, if you hear about all the work around knowledge graphs, you can see how it just naturally fits into the whole generative AI stuff, like in terms of that. But graph databases traditionally suffered from the problem of not being so efficient or scalable because it's connected workloads. And disks don't really map really well to connected workloads.
Yeah.
And we had the opportunity of this optimized memory that could also persist your data. And so to rethink the data structures that went into the graph database. So as we were doing that, and we did some evaluations, compared it against the contemporary popular graph database, and we could blow the performance out of water. It was highly scalable and low latency queries and very high throughput operation. So I was in the database space, looking at all these connected data models and all these things, and that kind of transitioned into this the research center I told you, and that gave us the opportunity to talk to people across different, like I was saying, the different verticals.
Yeah.
And the more we understood what they were trying to do, and we tried to map out their workloads, we were more, I guess somehow because of that database background and because of the, constant thinking about the hybrid memory storage stuff and data processing challenges, we just naturally focused on where does this data go? There was a lot of effort around, like, how do you do real-time deep learning? How do you do batch deep learning and understand and extract more and more information? And we just not we had the data, so we weren't looking at the ETL part of it at the time. We now have to, but we weren't at the time. And we just, by nature of that, got focused on, like, hey, there's a lot to do here. We can really make a difference. And the biggest thing was, like, as soon as we started thinking about this, we started working with, like, medical imaging example. And there was just immediate, like, learnings from the users. And we could combine our database and systems knowledge to solve the problem. So we're like, let's focus on the data management. And there are plenty of use cases where the data is available. You're not necessarily always looking at streaming it in. So it seemed like a good point to start.
Yeah.
And now, of course, as we've grown as a company, we've had to recognize and deal with some ETL challenges. And, part of that we can collaborate with partners. Part of that we have implemented in our own tooling, like how would you ingest data easily? How can you apply all these, like, embedding extraction and metadata extraction on the fly as the data is coming in? How do you, like, index it efficiently and scale? So those things now we've had to, of course, as we get deployed at different customers, but that's kind of how we focused in there.
The story that you shared yesterday, just about the coming, and you spoke really candidly about, your family and your daughter specifically. And I thought, like, wow, how human of an experience that you shared. There's a dog in here. Sorry. But I think my last question is, like, then how did you once you had figured out the problem, apply it to specific clients and customers and get them bought in, like, yeah, that's the solution we need. Like, I'm really interested in how you sell a data product like this. And so if you could just talk about that, and then I think that'll probably be excellent and take up all your time at the conference. So
Selling the data product is, I have to say, I worked on various levels of system stack, all the way from, writing operating system kernel to applications. Selling is the hardest thing I've done.
Yeah.
And it's very important to recognize that just because you have, so one of the biggest, the very first things I had to change in my perspective was, as systems researchers, you get really excited when you gain so much performance and you show so much scalability.
Yeah.
Right? But people don't necessarily care about that when they are starting a project or when they're exploring, when they have AI pipelines are complicated.
Yeah.
There's so much to figure out. Now we've gotten to the point where the models have gotten really good. But, when we started, there's a lot to improve. I mean, if you ran, the very first model we tried was AlexNet, you show it a brain lobe picture, and I think it gave a classification of it's a light bulb or some weird stuff like that. You're like, how cool is this? Looking at my medical imaging stuff, right? But now you show it, and it'll even give you, this is where you see not AlexNet, some new models. But so that's come a long way, but there's still a lot to figure. There's still a lot of where does the data come in? If there is an existing DIY solution that people have put together and it sort of works, is it worth the effort to switch?
Yeah.
So it becomes a lot about making people see that while the DIY solution might be working, you are constantly paying a price.
Yeah.
That technical debt, it's hard to quantify, but it is showing up in how much time your teams waste, in how often you have to fix multiple pieces, and how many different people you have to get in the room to solve the problem sometimes. And even then, it's hard. But the biggest thing we've realized is making people realize the opportunity cost.
Yeah.
Everything is moving so fast.
So fast.
If you take 6 months to prepare your data,
it's done. You're already behind.
Yeah. I mean, by then, you probably have heard 5 different new models.
Oh, exactly. I mean, Anthropic and OpenAI are constantly releasing these new models. OpenAI continues to push for GPT-4 out with new updates, but they're on the cusp of 5.
Yeah.
Claude just had, 3.5 Sonnet. They're getting ready to launch 3.5 Haiku and Opus. I can't wait. Artifacts has been incredible. And so I'm so excited to see where Aperture DB goes. I want to thank you so much for your event last night after hours, and then also just being willing to sit down and chat with me. I'm really looking forward to what you do. I know my company at Test Double, Brett, who you met last night, was really fascinated by some stuff, and he shared your company's information in our Slack. So I'm really excited. So again, thank you so much. Enjoy the rest of your conference, and I look forward to seeing where you go.
Yeah, thank you so much. And, if any of your listeners are looking for either a graph database or a vector database, we give them a blended solution.
Awesome. Yeah.
Ready for multimodal AI.
What site can they go to learn more?
ApertureData.io.
Thank you so much. You have a wonderful rest of your day.